We're going to get into graphing systems of equations today. So a system of equation is a set of two equations, and you have to graph them and see the coordinate that works for both of them. It's going to be where they intersect each other. So that x and y works in both equations. So just warming up, familiarizing ourselves again with the forms of graphing. Y equals negative 2/5 x plus 7 is in slope-intercept form. And when you're graphing in that form, you start with the y-intercept, which is 7. The y-axis is up and down, so you'd be up 7. Boom. Then you use the slope, the negative 2/5, to find your next point. So if the slope is positive, you go up and right. If it's negative, you go down and right. So we're going to go down 2, right 5. And if you're using a ruler, done. Otherwise, you can keep going down 2, right 5. You could also do both backwards. Up 2, left 5, up 2, left 5. And then you're good to go. That is the most common form of graphing, slope-intercept form. Tells you the slope, tells you the intercept. The next one was standard form, where the x's and y's are on the same side of the equal sign. Now you can always readjust it, get y by itself, and get it into slope-intercept form, or you could just graph it in the form it's in. So in standard form, the textbook would tell you, hey, substitute in 0 for x and solve for y. If I substitute in 0 for x, 4 times 0 is 0. So this is just going to vanish. So I say just write what's left if you cover up the x's. We'd have negative 6y equals negative 12. That'll get us the y-intercept. We also have to do the same thing to find the x-intercept. So we substitute in 0 for y, aka cover up the y's, and write what's left. 4x equals negative 12. We're going to solve both of these equations. 4x equals negative 12. If we divide by 4, we get x equals negative 3. We'll come back to that. Over here, we'll divide by negative 6, and we'll get y equals positive 2. These are the intercepts. It says our y-intercept is at positive 2. That would be up here. Our x-intercept is at negative 3. This is the x-axis, so negative 3 would be left 3. Draw your straight line through it. If you forget your ruler and you don't want to borrow one of mine, you could just figure out the slope here. If you look from left to right, it's going up 2 over 3. So you could keep that going. Just keep going up 2 over 3. You could go backwards, go down 2, left 3. I promise, if you got y by itself, you'd end up with the exact same equation, the same line. But to me, that's easier work to do what we just did than to try to get y by itself. And then the last form is point-slope form. Point-slope form tells you a point, and it tells you the slope. So the coordinate, the point, comes from what's with the x and y. If you look and it says x plus 1, point-slope form, if you look at the original formula, has subtraction built in. So it's always like opposite of. So if I see x plus 1, that means my x-coordinate would be negative 1. If you look with the y, it says y plus 3. That means my y would be negative 3. So you plot that point first, negative 1, negative 3. And then you use the slope to find your next point from there. Our slope is this negative 4, which if we're thinking of that as a fraction, would be negative 4 over 1. So we could go down 4, right 1, down 4, right 1. You could also go up 4, left 1. Cool. So now we're going to graph systems of equations, where we're going to pair up two equations at the same time, and we're going to find their point of intersection, where they cross each other. So here we go. Negative 1/3 x plus 5 and x plus 9. So if we're graphing that first one, we would start at positive 5, right? That's our y-intercept. And then our slope is negative 1/3, so we'd go down 1, right 3, down 1, right 3, down 1, right 3. We could also go up 1, left 3. Now you do want to make sure your lines are pretty straight when you're graphing the systems, because we have to find their exact point of intersection. So use a ruler, use the edge of a book or a folder. Otherwise you can count off with the slope, finding all those additional points. The next one, y equals 1x plus 9. You would start at 9, and then your slope's 1, so that's up 1 over 1 to the right. Now, we're going to have to backtrack here. We're going to go down 1, left 1, until we find where they actually cross each other. There we go. So the point of intersection is right here. So we list that coordinate. Now that is to the left 3, so our x would be negative 3, and it's up 6. So our coordinate would be negative 3, 6. That's our answer. That's not too bad, right? Now if you substitute those in for x and y in both equations, they work, both equations. No other set of numbers will work in both of those equations. That's what we're trying to find. So let's try some more. We got 2 more coming up right here. Ooh, y equals 2x plus 1. You start with the y-intercept. Start at 1. And then your slope's 2, so you go up 2 over 1. Could also go down 2 left 1. Look at that. I can't use a ruler on the board, so my lines always look wibbly and wobbly. The second one, negative 1/2 x plus 6, you'd start at 6, and then your slope's negative 1/2, so you go down 1, right 2. Now you can see already where they cross each other. We could also go up 1, left 2. And that coordinate right there is to the right 2, and then it's up 5, 2, 5. If you had extra time on a quiz or test, substitute them in for x and y and make sure they work in both equations. And this does, so that one's good. But try to put in some extra time for you on tests and quizzes to give you that chance to do that. All right, y equals negative 2x plus 8. You start at 8. Our slope is negative 2. Down 2, right 1. We could also go up 2, left 1. Cool, 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 cool. The second one, 3/4 x minus 3. You start at negative 3. Our slope's 3/4, so up 3 over 4. Boom, that's where they're going to cross. Up 3 over 4. So that point of intersection, it's to the right 4. It's up 0. So 4, 0. If you have extra time, plug it in for x and y, substitute it in, and solve it. Make sure it works out. Flip over those notes. We got 3 on the back. Ooh, we're bringing in some other forms here. Y equals 2x plus 3. No big deal. We've done problems like that. Start at the 3. Our slope is 2. Up 2, right 1. Down 2, left 1. All right, the second one is in point-slope form. So we pull out the coordinate, x minus 2. That means it's positive 2. Y plus 8. That means we're going to negative 8. The negative 3 is our slope. So we're going to go to 2, negative 8, which is down here. Whoops. Down there. And then our slope's negative 3. That would be down 3, right 1. Now we're going to have to backtrack it. So we're going to go up 3, left 1. Up 3, left 1. Up 3, left 1. That's where they cross. Up 3, left 1. So that coordinate is left 1, up 1. Negative 1, 1. Sick, dude. Sick. You look at number 5, that first equation. Negative 1/5 x plus 6. That's up 6. And then the slope is negative 1/5. Down 1, right 5. Down 1, right 5. You could also go up 1, left 5 a couple times. The second one, negative 1/5 x minus 1. You're starting at negative 1, and then you would go down 1, right 5, down 1, right 5. You can go up 1, left 5 as well. Our solutions to these problems are, where do these lines intersect each other? These don't intersect each other. And the reason is because they have the exact same slope, but they have different y-intercepts, different starting places. So they will never cross. Those are called parallel lines. If they never cross, this is one of those special cases where our solutions are, where do they cross? And they don't. So we say no solution. There's nothing you could put in for x and y that work in both equations. All right, last one. 2/3 x plus 1. You start at 1. You go up 2 over 3, up 2 over 3, up 2 over 3. You could go down to left 3 as well. All right. The second one, it's in standard form, so we could set up our two equations. Negative 2x equals 3 and 3y equals 3. We solve them both. Divide by negative 2. That will give us x equals negative 1.5. So it's going to cross at negative 1.5. That's there. Holy cow, that's on my line. That's a good sign right there. You do the other one, divide by 3. Y equals 1. Oh my gosh, that's also on the line. If you drew a line through these two dots, it would be the exact same line. If that's the case, if they perfectly overlap each other, that's another special scenario. And what we write for that is IMS, which stands for infinitely many solutions. These lines are always touching each other. So there's infinite little decimal solutions because it's the exact same line. Also, if you took that second equation and got it in the slope-intercept form, it would be the exact same thing. So if the lines are the exact same line, it's IMS, infinitely many solutions. Fun!